Okay, so now when we move to 6.2, let me label it. 6.2 homework questions. Oh, it's not, oh, okay, gotcha. What number was it on page 363? So this is the part where we moved away from the exponential stuff and started saying, hey, just combine like terms. So remember, it was kind of a different topic in 6.2. We were adding and subtracting. So on number 15, it says, you're given P of x equals 3x squared minus 5x cubed plus 2. It wants to know some stuff. Part A says identify the leading coefficient. The leading coefficient, that means the number that's in the very front, right? When you're deciding which one that is, remember you want your powers in order. So it's not 3. Don't be tricked by that. Remember, we generally like to see this stuff put in order. That makes it look nicer. So if you're going to talk about the leading one, the one that has the most effect, it's the variable with the highest power. That's what happened? Good. I mean, it's good that you see it now instead of later, you know. So if we write it from highest power down, it doesn't change anything. It just makes it more obvious to us. You didn't have to rewrite it to see it necessarily. But looking at the highest power, that leading coefficient is that number right there in front when it's put in order.
Degree would be 2, right? Which is 3.
Okay. Let's go in order. This was part A, right? The degree, to answer your question, then I'll do it in a sec, that's the highest power, floating. But the second thing it actually asks you in part B is it says, okay, what's the constant term? So you've got the leading coefficient and you got the constant term. Okay, you guys know, or maybe you know if I remind you, for modeling equations, like those financial ones like on the test, that you have numbers attached to variables that we call stuff like variable costs, right? Then you have your set cost or your constant cost, the stuff that's not attached to a letter. So which one does it make sense to be? Which one's going to be the non-changing, the not variable one, the constant one? The 2, the regular number, okay. So that's your constant. Good. And you can remember it's the one that's not varying, it's constant. It's not got a variable. State the degree. The degree, remember, is the highest power. If you had more than one variable in a certain term, in a certain piece, you'd add those powers in that piece, remember, to get the highest power. But in this one, it's just that 3.
What would the curve be?
Good question. To get the curve, you take the degree and subtract 1. So in this one, we'd have 2 curves. It'd be like a W on the graph. Maybe an upside down W, since we have a negative in front. But we learn about that in different math classes, where we'll play with it more. But yeah, some kind of a W, that's what we know. Actually, it wouldn't be a W, would it? If it's 2 curves, it's like that. Or like that. 1, 2. Okay, yeah. Go see, there's a curve, there's a curve, there's a curve, there's a curve. Let me hit undo because that looks like horribleness. Okay, but yeah, 2 curves. I guess a W is actually 3 curves. I was just visualizing it funny in my head. But yeah, the idea is you take that degree, you take away 1, so 3 minus 1 tells you how many curves. Thanks for reminding us of that, because that was one of the reasons they would even care. That's why you care in another math class coming up. Okay, other homework questions from 6.2. Were you guys okay adding and subtracting? The biggest thing was if you had a negative in front, you had to distribute that thing. That was the place you would have had mistakes. And I'll tell you to be careful for the test, even though it seems probably easy right now. Remember, it's because you did 6-1 and 6-2 on separate days. If I mixed it up on you, it might make it seem harder. So for your test, go to the review section and take it seriously. You know, try stuff out of order and make sure that you wouldn't be tricked. Kel.
21. Explain on that one. After you get the answer, where do you start at on the graph?
Well, the way we learned how to do it in here was to just pick some numbers, like for x, maybe a -2, a -1, a 0. And then you find the y's that go with it to get the curve. Okay. So you're wanting me to explain what?
Well,
do you want me to do it for you to help the problem?
I figured out, you know, the X and Y, and then I got like 3 different dots, or no, 4 different dots.
So how do you kind of connect them?
Yeah.
Okay.
Which way do you go?
Well, you always go left to right like a book, but it could have been hard if you didn't get enough dots.
Yeah.
Let's see, on 21, if you ever, you can always add to the table if you don't have enough. But let's look at what you've got. For 21, they've given us this function, r of x is equal to x cubed plus 2. And what we've learned so far, you'll learn other techniques later on in math, but so far we've learned, you know what, to generate any picture, I can just put in x's and y's. So we said that normally going between about a -3 or a -2 and a positive of the matching one, 2 or 3, would work. Kel, what did you use?
2, 1, 0, and -1 on the X side.
Okay, since you used a positive 2, I'm going to go all the way to -2, okay? Because I'm going to make it balanced. I mean, sometimes they won't even be centered, but I'm just going to do it that way. Okay, so let's see. With this one, when I plug in a -2, I'm getting a -2 cubed plus 2. What's that equal to? Let's see, 2 times 2 times 2. That's an 8. Is it going to be positive or negative? Negative because it's an odd power. So is that negative coming back out? So I have an 8 plus 2 is 8 plus, oh, -8 plus 2, you're right, is a -6. And then 1, so let's plug in a 1. We got a -1 cubed plus 2. So that's a -1 since it's an odd power. Plus 2 gives me 1. Check my math here, we're doing this all in our heads. Okay, so then we have 0, let's plug in a 0. We have 0 cubed plus 2. What are we getting? 2. When we put a 1 in, 1 cubed plus 2, well 1 plus 2 is 3. Then we have positive 2 cubed plus 2. So that's a positive 8 plus 2 is 10. Okay? So we have several points. Let's plot this thing together. I'm going to draw me an x and y axis. Again, if you have graph paper, that's always nice, but I don't require it. We're just getting the main idea right now. Okay, so we have, let's see, when x is -2, y is what? Okay, when x is -2, y is -6. So something like that. It's a little low, but my pen just did that. Okay, then we have when x is -1, y is 1. So something like that. Then we have when x is 0, y is 2. Something like that. When x is 1, y is 3. Something like that. When x is 2, y is 10. 3. Really? Did that really make it that messy? Okay. Something like that. So when you look at it, you look at it like a timeline, or like you're reading a book left to right with the x's. So my lowest x was a -2. I'm going to go from the -2x to the -1x. I just connect them in order, okay? That's the way it works left to right. So as I connect it, I'm getting something like that. And I know I'm going to go from this one to the next one in the center. I'm going to wait until I don't know in a second because I'm not sure how to curve it yet. Same thing for the center one to the outside. I'm going to save those and just connect the rest to see if I start to see the shape. Because we know with this degree of 3, how many curves do I have? So we know when we're connecting these dots, we're hoping to see 2 curves. What makes sense? Would it make sense for this thing to go kind of up and be sloped down like that, or to be like a cup, like going the other way? Kind of up, because can you kind of see a curve between these two already, a little bit? Now, again, on the test, I won't be super strict. If your intuition is wrong and you cut the thing the wrong way, if I see two curves and the dots connected, I'll say, okay, this is 070. We've not done that much detailed graphing. The person has the main idea. But ideally, you would have chosen this way and then that way. Biggest thing again, guys, we've got two curves. So if you had even done it the other way, I would want to see a bend where I've got two curves showing on that picture. And technically, on these pictures, you want to show arrows on the end. Because we only tested a small sample, but we're assuming that picture keeps going. In fact, we actually know it does. Because when you look at the domain, are there any forbidden X's? No. You get the forbidden X's, you get holes in that side-to-side part of the picture when you have something in a fraction. Remember something on the bottom, because you can't have bottom in the denominator, remember that? That was on the test we just took. So on this one, there's not even a fraction there. All X's are going to work. You're going to get arrows going both ways. Okay, good. And we'll learn about range more later, but that's good enough for right now. Okay, and objective B, adding and subtracting, was that okay? Good. Tonight we're going to multiply. So tonight's lesson is 6.3, multiplication of polynomials. And I'll tell you, just like last time with 6.2, how 6.2 was kind of nice, it was a nice break. That's what this is in my opinion. It's different though, so you don't want to mix stuff up. Also, next class, put on your thinking caps because 6.4 is not an easy one. It's dividing. That's probably the hardest thing with polynomials. And then we'll be basically done with chapter 6. But it's not too bad, but it's just, you know how 6.2 is you just kind of did it automatic, put like terms together? That's what, in my opinion, this one it's kind of like. Versus